Hi, how's it going? Hope it's going well for you. I really hope it's going well for you, okay? I want to talk to you about a really important and useful result, okay? It's about differentiating exponentials. It's about how to differentiate that, y equals 2 to the power of x, okay? Of course, here, the more difficult thing is that x is actually a power itself, okay? It's easy differentiating it when it's x squared or when it's 2 to the power of x. What have you got to do? Well, my preferred method actually is to use implicit differentiation. If you've seen my video on implicit differentiation, great, you're probably ready to go. If you haven't seen my video on implicit differentiation, maybe you just watch that, okay, because that's the method I'm going to use, okay. So the first thing I'm going to do is use natural logs. Of course, if we're using calculus, we're using base E for our logarithms, so natural logs, okay, and just take natural log of both sides, okay. Why do we do that? Because we use the power law, you see. So the general approach in mathematics is when you want to bring the power down, to be able to do something with it, use natural logs to do that. So you've got natural log of y equals natural log of 2 to the power of x, and then using the power rule, of course, you've got the x goes in front, so it's natural log of y equals x natural log of 2. Now this is where I use implicit differentiation, okay? You might have seen the method before when you make y the subject, okay? Well, if you make y the subject, what you're going to get? You're going to get y equals e to the power of x natural log of 2, and then you do dy dx that way. You might have seen that, okay? But my approach actually is to use implicit differentiation because it's very, very easy. You just differentiate both sides with respect to x, okay? So on the left-hand side, you're going to get 1 over y, dy dx. Remember, the method is differentiate normally, as it were. When you differentiate natural log x, you get 1 over x. So natural log y, 1 over y, except because it's in terms of y dy dx, okay? I'm not going to explain the implicit differentiation all over again. Watch my video if you want the explanations to why you get this. And on the right-hand side, it's just natural log 2, isn't it? Because x times natural log 2, differentiate that, you're just left with natural log 2. And then we'll make dy dx a subject, so we'll multiply by y, so we get dy dx is y times natural log of 2. What is y again? It's that, y equals 2 to the power of x. So here's our answer, our result. Dy dx is 2 to the x natural log 2. Okay? And that is it. Okay? I'm going to show you the more generic approach. That is when you're differentiating a to the power of x. Now, I chose 2. It could be any other number. It could be 3 or 5 or 6 or something like that. Okay? Yes, it does work for decimals as well, in case you're asking. Okay? It's just easy to use whole numbers and positive whole numbers because it's more manageable, isn't it? Okay. So the approach is exactly the same. Natural logs of both sides. Use the power rule. Differentiate implicitly. Put y on the other side, and then write it as that. Okay. So your general result. It's probably a good one to write down actually. When you're differentiating a to the power of x. Obviously a is not 0 because that gives you a different case. Obviously y equals 0. You know what that is. And yeah, you'll get a to the x natural log of a. Now let's do something interesting here, okay? Let's just suppose it is e to the power of x. So I'm choosing my number a to be e. Alright? I'm not choosing another letter for another letter. I'm choosing the number e. Okay? 2.718281828, that one. Okay? And let's just use the same approach. Okay? At the end of it, what we're going to get, if we use the same approach, we're going to get dy dx is equal to e to the x multiplied by natural log of e. And what is the natural log of e? It is 1, of course. Hence you get dy dx equals e to the x. Okay? So that's a nice little way of explaining why the derivative of e to the x is the same. It is e to the x. Okay? I'm hoping that is useful too. There's an example coming right up in terms of how you might use that in an exam style question. Right, let's have a look at an example then, shall we? So the curve C is given by the equation y equals 100, subtract 2 multiplied by 3 to the x. Okay. Remember, you cannot simplify that as 6 to the power of x. The only reason I say that is because I still do see sometimes year 13 students doing that rather silly thing. Okay. Remember, it's rules of indices, 3 to the power of x multiplied by 2. So don't do anything silly there, please. Please. Okay. The normal to curve C at the point 346 crosses the x-axis at point P. Find the exact coordinates of point P. Right. So when it says find the normal, it means we've got to differentiate, doesn't it? So we've got to differentiate this. So I'm just going to remind you about our useful rule that we're going to use there. If you can memorise this, that's great. You can just use it and quote it. However, if you can't memorise it, or if you've forgotten it, you'll have to do it the longer way. Okay, so the method I showed you just previously about how to differentiate a to the power of x. All right. So we've got 3 to the x there. So let's just write this in. So suppose y equals 3 to the x. Okay, I'm just taking that bit of the equation there. Then dy dx, what's that going to be? That's going to be 3 to the x multiplied by the natural log of 3. Okay, so that's that bit. All right. Now let's go ahead and do this. So this is not a bad one actually, because y is the subject. So that's quite straightforward. So when we differentiate it, we get dy dx equals, that would be 0. We know the derivative of 3 to the x is that, then just going to multiply it by -2. So that would be -2 multiplied by 3 to the x natural log 3. That's dy dx. Okay. Next, because we're finding the equation of normal, we need to find the gradients. So we'll substitute this point in. Well, x is 3 is what we're going to use. We don't need the y coordinates. So at x equals 3, we're going to have dy dx is equal to -2 multiplied by 3 cubed is 27 natural log 3, and so that's going to be -54 natural log 3. Okay, and that's dy dx. I'll just highlight the word normal now, because that's not the gradient we want. That will be the gradient for the tangent, but we need a normal. So what we need to do is we need to, let's just write down m is equal to multiply by -1 and take the reciprocal, so it's going to be 1 over 54 natural log, what am I doing there? Natural log of 3. Sorry, it shouldn't be joined up, it should be L and then N. Sorry for that. And then we just use the equation, okay? Y minus y1 equals mx minus x1, so y minus, what's the y got, 46, equals m, so it's that, 1 over 54 natural log of 3, and then x, well, can I just get rid of this now? Of course I can, because we don't need that anymore, do we? X subtract 3. Okay. Multiply both sides by 54 natural log 3. Okay. And then you get y natural. But I'm just thinking, do I actually need to do that? Okay. It says it crosses the x-axis. I'll tell you what I'm going to do is, I'm just going to substitute in y equals 0 straight away. Because when it crosses the x-axis, okay, that tells the y coordinate is 0. So I don't actually need to rearrange that to begin with. I'm going to say when it crosses the y-axis, y equals 0. So you've got y equals 0, then you've got 0, so you've got -46 is equal to 54, 1 over 54. Sorry, that was my noise for, that was a silly, almost slip there. X minus 3. And we want to find the exact coordinates of the point P, okay? So we want to find the x coordinate, don't we really? So let's just put this onto that side. So we want to do 46 times 54. Wait one moment. I'm just going to get my calculator, because that's something I'd rather just quickly do with my calculator. It's always handy on my desk. So that's going to be -2,484. So that's 46 times 54. Okay. Natural log of 3. So what I've done is I've just multiplied both sides by that, is equal to x subtract 3. Okay. So that means the x coordinate then has just got to be 3 plus, no, 3 subtract, still negative, 2,484 natural log 3. All you do is just put this onto that side. Okay. It's a pity I've run out of space, because I kind of need to write down what the final answer is. It does say find the coordinates, and I'm always saying this, if it says find the coordinates, write your answer as coordinates, okay? Otherwise it's not finished, is it? So therefore coordinates are 3 minus 2,484 natural log 3, and the y coordinate is 0. There, and it's done. Okay. Well, I'm hoping you found that useful. Okay. I'm hoping that you enjoyed that. Okay. Next thing, of course, practice. Practice as many questions as you can involving differentiating exponentials. Right, I'll see you again.